So the key actually to graphing these functions is to remember or memorize what the sine, cosine look like. Now for now, I'm going to go through one of them and just show you if you were to graph the sine of x. If you never saw it, get your calculator handy. And we're going to make a table here. See that? You see that?
Usually it's a couple tries.
I need to write small so it'll fit there.
I'm clicking it like 7 times. It doesn't work.
Now, if you don't have a calculator, use your iPhone. If you turn it sideways, you got a scientific calculator. Someone said, I didn't know that. I said, well, I'm a math person. I use that thing all the time. So what we're going to graph, we're going to pick values for x, and we're going to see what the y value is. Now, I can graph them in radian or in degrees, but I'll make it easy on you. I'll do them in degrees for now, then I'll switch to radian. So we'll use x here and sine of x. Let's start with 0 degree. Sine of 0 is 0. You can check these numbers on your calculator. I'm like bored, I memorize things. 30 degrees. Sine of 30 degrees, 0.5. Somebody was bored with me too. $60 degrees. Sine of 60 degrees, 0.866 or 87. Again, just push the button on your calculator. Make sure you calculate in degree mode. 90 degrees. That's a 1. $120. 0.87. I'm going by 30. I'm getting tired of stopping to draw the lines here, so I'll just go like this. Hopefully I have enough here. 150. 0.5. 180. 0. 210. Negative 0.5. 240. Negative 0.87. 270. Negative 1. 300. Negative 0.87. 330. Negative 0.5. 360. 0. 390. Back to 0.5. And it keeps going. So I'm going to put notches here on that paper, everything by 30. That's 30, 60, 90, 120, 150, 180, 210, 240, 270. I can't write all these numbers, like there will be not much enough space there, or not enough space. 300, 330, 360, and keep going. And if we go and find where these points are, and we connect them, when x is 0, what was sine of x equal to? 0. When x is 30, what was it? Let me put a scale here, 0.5 here, maybe. And this is the 1. This is the negative 0.5. This is the negative 1. So when it's 30, it's 0.5, right? When it's 60, it was 0.87. A little bit less than 1. When it's 90, was what? 1. 210 was what? 0.87. Shut up, Murta. No, I'm talking to Murta. She's yelling there. 150 is 0.5. 180, back to 0. 210, minus 0.5. Next one, minus 0.87. Next one, minus 1. Negative 0.87. Negative 0.5. 0. And when you connect these points, what do you notice the graph looks like?
Wave.
It does look like a wave. What's the highest point it goes to? 1. What's the lowest one?
-1.
Negative 1. So this is the graph of sine of x. If you just put that picture in your head, I'll give you the cosine in a minute, we'll be in good shape. Now, I stopped at 360, but you know it doesn't really stop. You can still go 390, you can go the next number. So this graph, actually, if you continue with it, it will continue to go now on and on forever from both ends. What do I mean from both ends? Even for negative values. You know? It just keeps going. I'm only going to be interested in one sine wave, just one of these. Then we'll show you what will happen as we go through them. So what about the cosine? What does the cosine look like then? So let me go back. Now I'll do the sine again. I'll do one sine wave. I'll do them on top of each other. So you get to see them. So you get to see the difference between them. This will be the sine. That will be the cosine. I'm not going to pick points for the cosine or the sine. I'm just going to put the graph for them. You saw one. The other one is identical to it. So the sine of x looks like this. I'll make it a little bit bigger. That's the sine of x. The highest point is 1. The lowest point is what? Minus 1. The highest point, it happens when? 90 degrees, or in radian, that's pi over 2. When we be talking about, with the graph, we always talk about radian. Radian, that's pi over 2. The 0 here happens where? 180. In radian, that's what? Pi. The lowest value here, that's 270. In radian, that's what? 3 pi over 2. Yep, very good. And the last one is what? 360, which is what? 2 pi. Let me mark these spots. So that's the sine of x. Let's look at the cosine. Let me mark these spots here, so you get to see them where they're happening. So this is going to be the 90. This is going to be what? The pi, right? I could go for a piece of pie. Oh, I don't mind that. That's a sign of a good weekend. Next time you see me, I'll be even bigger. What does the cosine looks like? The cosine is similar to the sine, but it looks like somebody pulled it back by 90 degrees. So the cosine will start high at 1 here. Notice, just imagine pulling this back, like putting the y-axis right here. That's what you're going to have. So it hits this point, then it goes back to -1, back to 0, back to 1. This is the 90 degrees again, the pi over 2. This is the pi. This is the 3 pi over 2. And that's the 2 pi. Cosine x. If we can just put these two pictures in our brain, we can graph any function we have. I call the cosine of x the Karate Kid. Remember the first Karate Kid movie? Mr. Miyagi, Daniel's son? When he goes to fight, he puts his hand up in the air like this. That's what the cosine. The hand is up, it comes down, then it goes back up there. So that's what this one is. Except chop my head off and go like this. Yep. That's what that function is. Cosine of x. So in section 1, 10.1, what do we do? What does the a do for us? What is, if you have a number in the front, we know what sine of x and cosine, but if you have a number in the front, what is that number going to do to the graph? That's really what the topic in section 10.1. Amplitude. Somebody was reading the chapter. Very good. So let's look at the number a, or the letter a. Graph y equals a sine of x. The amplitude, which is how high the graph goes, it's always equal to the absolute value of a. Always. So the word amplitude, how high the graph is going to go. So now example, let's say I want to graph y equals 3 sine of x. I'm going to start with the basic sine function. I'm only going to show you one wave, one cycle. It's called a cycle, actually. We'll talk about it. So what's the sine function? Just remember what the picture of the sine function looks like? Yep. It looks like this. Don't make it too high. You'll see why I said don't make it too high. It looks like this. And again, I'm going to write these numbers on them, hoping by the time we finish writing these numbers, they'll stick in your head. This is what? Pi over 2. Let's use radian. You're right, but let's use radian. This is pi. This is what? 3 pi over 2. And this is 2 pi. How high does it go? No, this one, the sine function. 1. And how low? -1. So this dotted line, if you can see it, that's really sine of x, not the 3 sine of x. I'm going to start with that. So what does the 3 then do? It's going to raise it up to 3 units. So it's going to have the same shape. It's going to cross at the same points. That's what the 3 does. It's going to make it go as high as what? 3, as low as -3. Still going to peak at the pi over 2. Still going to cross a pi. Still going to be low at negative or 3 pi over 2 and back to 2 pi. These numbers don't change. So it's the same thing. So that's what the amplitude does. Let's try another one. I'll give you a minute to think about it. I'll put it there. I won't be quiet for a while because the camera's running. You try y equals 2 cosine of x. Start with the cosine function. What does it look like? Then see what the 2 does. So let's begin with the cosine of x. It looks like the Karate Kid. Remember that? I'm going to use dotted line for that because that's not the correct, that's not the answer to my problem. This is the minus of the plus 1, and the bottom here is what? The minus 1. This value is what? Pi over 2. This value is pi. This point, 3 pi over 2. And the last one is what? 2 pi. Again, the orange color that you see there is just cosine of x, not the 2. What is the 2 going to do? Amplify that signal. So it's going to start high at 2 here. It's going to go down how low? Negative 2. Back to 0, back to 2. My amplitude here is what?
2.
Yep. It's the absolute value of 2, which happens to be what? 2.
2.
How high does it go? 2. Let's try 2 more examples, then we're done with this section. Am I going too fast? I didn't have my coffee today either. My hands are shaking. Let's try another example. Here we go. Let's graph y equals 1/2 sine of x. Damn it. I meant to say 1/2 cosine, but it's all right. 1/2 sine, that's fine. Again, I'll start with sine of x. I'm going to make it a little bit bigger here. Pi over 2. Pi. 3 pi over 2. 2 pi. Again, I memorized that shape. That's sine of x, the pink. Or orange, not pink. How high? 1, negative 1. Now the purple one is going to be the answer to this. So what's the difference here? It's going to go half as high. Oh, looks a little bit crooked there. That's 1/2. And this is what? Negative 1/2. So my amplitude, so the purple one is 1/2 sine x. That's what the purple graph is the 1/2. The orange one is just sine of x. So my amplitude is the absolute value of 1/2, which is 1/2. I keep writing amplitude, because in section 3 we're going to put the pieces together, and that will make sense. The amplitude with this and that. One more example, and I'm done with section 10.1. 2 more to go, we'll be going home. Tonight's what, Thursday night?
Yes.
Oh. Pizza y uno. 50 cents wings during the game. I might have to hit that on the way home. Let's try one more. Negative 2 cosine of x. Negative I did instead of plus. Let's make the cosine not so big. So there's the cosine. Starts with 1, right? This is the negative one. Now this is negative 2. If this was a plus 2, if it was a plus 2, let me cover the minus sign. So this is just cosine of x. Again, let me put the numbers here for now. Pi over 2. Pi, I'm sure you're sick and tired of listening to these numbers. 3 pi over 2. And 2 pi. But I bet you most of you now got them. Just keep writing them and writing them and writing them. You'll know it. If I didn't have the minus 2 here, let me do this in 2 steps. If I didn't have the minus, if that was a plus 2, what does the graph will look like? Twice as high. This is the 2 here. It will look like this. I'll make it also dotted line. That's the plus 2. This is plus 2 cosine of x. But I have a minus, not a plus. So what do you think is going to happen? Not shift down. Up, flipped, exactly. The plus becomes the minus becomes a plus, called invert. So the graph will be actually, this is the 2 here. The minus sign is going to flip the entire graph, is going to make it look like this. That's, yep, that's the minus, you see? Just your eyes are bad. Close enough. So that's actually the minus 2 cosine of x. That's what the minus sign does. It takes the graph, the plus becomes a minus, the minus becomes a plus. Flips it complete, like you're looking at your mirror.
So the amplitude is still positive.
The amplitude, good question, still what? 2. Because always the absolute value of negative 2, and that is a 2.